Here's an example of reading through and adding some details based on this pseudocode. So here we have this request that we're going to initialize num to the next integer read in from the console. Okay, so with that as our goal, our first goal, we see that we've got a scanner, we're within a class, we've got public static void main. And so we're going to create and initialize. So we're going to start off with an int num, and we're going to set it, we're going to initialize it to the next int read in from the console. So we're going to use our scanner input, and we're going to read in that next int. Okay, then that's done. We're going to take on that next line, which says while num is not equal to -1. So we're going to have a while loop while num is not equal to -1. We're going to have a bracket, and we'll make sure to close it after the fact, but first we need to go ahead and figure out what to do here. So while it's not equal to, we're going to system.out.println, and we're going to print num. Okay, and that line's done. We'll do the next piece, and it is, we're going to set num to the next int read from the console. So num equals input dot next int. And that's the end of our while loop. And that is all we've been asked to do. So that's done. Cross it off. And go to the next one. So the next pseudocode that we want to implement is we're asked to initialize count to the next int read from the console. We've got a scanner input. So what that means is we want to go ahead and it's going to hold an integer, and so I'm going to call it int count. It's going to be the next int read from the console, so it's input dot next int. And then on this line, we're saying for I equals 0 to count -1. So we're going to go for int I equals 0 to I to count -1. So I can either say to I less than count would be one way to do it, or if I was following this pseudocode, I would probably do less than or equal to count -1. Both will work. I plus plus bracket. Then up here, we're going to move to that next line. Initialize num to next int read from the console. Okay, so while we're in there, num is equal to the next int read from the console, and then the next thing we're going to do is print again. System.out and end. Okay, and so that was that print line. Okay, next. So translate the following pseudocode into Java. So we're going to do that. Here we go. We're going to initialize x to an array storing. And so we can go ahead and do that. We can say int bracket x equals, and it can be 2, 3, and 1. set the last element of x to 4. Okay, so x bracket, and we know that the last one is at index. So we start at, just to look at it, 0, 1, 2, right? So that means that what we want is to set x bracket 2 to 4. Get rid of that. And we can say print element 0 of x. System out dot print line x 0. Okay, and that's it. Now we're going to initialize, yeah, we're good there. We're going to initialize a 2D array. So int bracket bracket 2 dimensions x is equal to, and we can go 2 comma 3 comma 5 comma 6, and it says set the last element of x, which is going to be this one, which again, this is row 0, this is row index 1, column index 0, column index 1. And so the last element in this is that 6. This is row index 1, column index 1. And so we're going to want to, why is it deleting? There we go. So we're going to want to set the last element x 1, 1 equal to 8. Don't forget my semicolons. Print the very first element of x. So this is the first one. So this time we're going to output system.out.println x 0, 0. Okay, next question. Initialize an int array called x2. So here we have an int array, x is equal to 5, 9, 1, 5, 6. And it says initialize min to the first element of x, initialize max to the first element of x. So int min is equal to x bracket 0, int max is equal to x bracket 0, and then now it says for I equals 0 to the length of x minus 1. So for int I equals 0 to as long as I is less than to the length of x. Oops, sorry. Up to and including x dot length minus 1 I plus plus. Then it says if x at index I is less than min. So it says if x at index I is less than min, set min to x at index I. Okay, so min equals x at index I. Okay, it says else, oops, we need a closing bracket, else if x at index I is greater than max, so this says x at index I is greater than max, then it says set max to x at index I. And then we'll close that for loop. and just make sure this is above here, but that's where we want to be. Okay, and then that's it. I could probably just write that better, but so I could finish it off. There we go. Okay, so next question, which is write the code to solve the following problem. You must read in 10 integers using the provided scanner and place those values into an array of 10 elements. Once it's been filled up, you need to loop through each element, determine what is the smallest non-negative value and how many duplicates of that number there are in the array. Okay, so several ways to do that. We'll just go ahead, read in 10 integers. So that's the first piece of that. So we're going to read in 10 integers, and we can do that pretty quickly. We can say for int, actually here I'm going to go smaller for a second, for int I equals 0, I less than 10, I plus plus. We're going to read in 10 integers. So, and we're going to hold them, not only are we going to read them in, we're going to hold them in an array. So before I do any of that, I'm going to move that down for a second, a little harder to do with a real pen. We're going to say int bracket, we're creating an integer array to actually hold this. So it says an array of 10 elements. And so we'll call that R, and it's going to be a new int array of size 10. Okay, and now we have a place to put them. And so we're going to read in the next pieces, and we're going to set the array of index I equal to input dot next int. Okay, and so now we've read them in, and what we can then do is, it says once the array has been filled, you need to loop through each element to determine what is the smallest non-negative value and how many duplicates of that number there are. Okay, so that's a few different pieces. And then what we can do is say, okay, so loop through them all. And we can find the number of duplicates later. But the first thing we want to do is find the smallest. So we can have something like a min, which is going to hold that smallest value. And we can use an enhanced for loop, for instance, to loop through that. So we can say for int value in, value in our array, if value is less than min, then min equals value. So we can use this enhanced for loop because we're not trying to write anything to this array. We're just trying to grab that value. Okay, and so that would find them all, but now we'd want to go through and find how many duplicates there are. And so we would want int dupes equals 0. And we can say, we can do the same thing for int value in array. If that value if that value is equal to our min, then what we want to do is set just dupes plus plus. Okay, and that's the end of that loop. And so then the only other piece that we want is to do some output, right? So we're going to output. I'm going to do it all in one line because I have no choice. That's fine. System that out, that print line, and what is it we're trying to output? We're going to output smallest value and duplicates. Okay, that's okay. Smallest plus min. And then because I need to do it all on the same line, I'm going to go like that and type duplicates. So there we have it. We can print it all out, and then I can fit it on that last line. Okay, last piece here. There are exactly 3 errors in the following program. Explain how you would fix those errors, and we'll just take a look at them. They're the lines that are highlighted, right? So there's this one, there's that one, and there's this one. And what I can see, so I'll just quickly look through and see what they are. So we've got the original array is set to 1, 2, 3, 4, 5, and size is the original array dot length times 2. This is an array length, right? And so what we know about array length is that length of an array is mutable, and so it's not a method, that's a property. And so we would change this to dot length without the parentheses times 2. Okay. So then this one says, so then we have this other piece, and we're letting I run from 0 to I less than or equal to 5. And we're using that index to loop through the size of our array. But specifically, we can look, if we look at our original array, this is its size, 0, 1, 2, 3, 4. If we left it as it is, that piece there, that's going to have, that's a serious problem because we only have 0, 1, 2, 3, and 4 as indices. And so if we left that as less than or equal to 5, that would be a problem. So the way that we'd fix that is that this should be changed to I less than 5, and that would fix the problem, or we'd have an out of bounds error. Next question, here we have, so then we loop. So on this line, what's happening? We're setting the values in new array equal to those in the original array, and then we have a loop that goes from I equals 5 to size. So if it's because we've increased it with this line, I mean, functionally, what we had an original array, 1, 2, 3, 4, 5. Then we created a new array on line 5 right here, and it had the size, which was twice that of the original length, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we, in these lines, we populated 1, 2, 3, 4, 5, the contents of the new array, but then on lines 12 to 14, it says for I equals 5 to less than size, you're going to set that to whatever our index is plus 1. So that's going to carry on 6, 7, 8, 9, 10. Okay. So then we have this weird statement here. And there is an error in it. I mean, it's useless. There's a couple ways to think about it. But what it says is set original array, which is at index 0, which is this guy, equal to new array at index 0, which is this guy. And they're already the same. First of all, index 0 was created from the other one. So why anyone would want to do that, I'm not sure. The only thing that you could think is that maybe they wanted to do this exact thing, but not have the index. And so that would reset this. That would say, okay, well, original array, now we're actually pointing, both original array and new array are pointing to the same reference, the same location. So either you could say get rid of it or not. So here we say complete the code below so that it will calculate the sum of each column of the number grid and store the result in column sums array. So we're going to try to calculate the sum of each column of our number grid and store the results in a column sums. So we can go ahead and do that, and if it helps to think about the array more like this, our number grid has row 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so what we're being asked to do is, if you think about what that looks like, we've got our number grid. We're going to want to take the column sums, and we're going to have another column sums array, and it's going to hold essentially that. So it's going to hold a 12 and a 15 and a 18. Okay. And so we've got a row count, we've got a call count, we've got a call sums already set up for us to hold it, and we even have started us off with for int call equals 0 to call list and call count. So that's already looping. That's starting with 0, 1, and 2, the different columns, which is great. And so we're situated within one of the columns. We start off in 0, and then we'll move our way over. And now to get that, all we have to do is loop through the row, right? For int row equals 0 to row less than row count, row plus plus. We are going to, do we have a way to hold it? We don't, so hold on one second. I'm going to move this down a little bit. Oops, not all of it. Move that down a little bit. And I'm going to first create a way to say for each column, we're going to have to start off with sum equals 0. And then while we're in there, we're going to say sum plus equals. And we're going to add in, it's called number grid. Is that what it's called? Number grid. And we want to be in, the row and the column call. We're going to add that to the sum. And so that loops, as we loop through the rows, we're going to add that piece up. And then we'll get to the end, we're going to say call sums of call equals the sum, whatever we had just calculated. And so it says store the results in that array. And so functionally that does it for us. We've done the work, and now the hard part is done, and they do the for us because they do the output for us. Okay. And that's it. So that's where we're at.